Okay, that's not what I'm saying. We did great as a class. I just finished talking about how proud I was. Okay. So, are you ready? Shh. This is the part where I get to start talking and you're stopping. Okay. So, are you guys ready? Okay. You spill that in here? Okay. So, everybody look at the front of the really cute pink foldable we just made. Cute. So, watch. This is a little math humor, okay? So just bear with me for a minute. Are you ready? So, you see how it says R-A-T, like rat, 2-E? You got it! Ratatouille, get it? Ratatouille? All right, you guys, why is nobody laughing? I'm so sad that you're not as impressed with that as I was. What? Ratatouille. E-Y is E. Ratatouille. My first name is Christy. Y. E. Yes. Oh my gosh. No, I don't care. Now I'm so sad. Like, I thought I was bringing humor, and you've just look. I'm getting some tears. All right. So I'm going to come back to the top. Look at the R. The R is going to stand for roots. Yes. The A is going to stand for asymptote. Specifically, the vertical one. Because that's exactly why I say it that way. I know. Asymptote. Okay. So vertical, the vertical asymptote, we can never cross. You can never cross the vertical asymptote. So that's why it gets to be all by itself, the vertical one. So the root is what makes the top 0, and the vertical is what makes the bottom 0. Okay? I'm going to come back to the T, but it's going to stand for two things. Tangency or togetherness. Togetherness. The E is going to stand for end behavior. And end behavior means the limit of f of x as x goes to plus or minus infinity. And these are the horizontal asymptote and the slant asymptote. And they're separate from the vertical because the vertical you can never cross, but you can cross a horizontal and a slant. And we'll talk about that when we graph. And the Y stands for y-intercept. The Y stands for the y-intercept. So if you open this up, the P stands, here, let's fill this in. The P stands for parent function, and this stands for point discontinuity. Point discontinuity. So what we did all last week and what we took this week and what we took the test on was the properties of a rational function. And so what we're going to do, like in the far, far off distance on Monday, like way far away, like not today, right, but way far into the future, we're going to graph rational functions. And this is how we're going to do it. So the first thing we're going to do is this, the P. Because it's one of the letters I want you to remember. So P stands for, does it have a parent? And by parent, I mean the 1 over x or the 1 over x squared. If the answer is yes, then we're not, to graph the function, we're not going to have to do anything. We're just going to do the transformations. And let me show you what I mean by that. You do not have to write this down, but I do want you to watch so you know exactly what I'm saying. So if we're graphing a rational function, it's 1 over x. So if I graph that, where are the asymptotes on the rational function? That's what it looks like, but where do the asymptotes go? Right? The x and the y. And what did I say you could never cross? The vertical, right? So if I have a vertical asymptote here, if the line is approaching this, I can't cross it, so it goes up, right? And the same here. As the line goes this way, it can't cross it, so it has to go down. It forces it to go down. And that's why the rational looks like the line blown apart. And the reason we have the positive and the negative is because if I put a negative x in, I get a negative y. But if I put a positive x in, I get a positive y. So we get the line blown into those two quadrants, okay? So we also had this one, which was 1 over x squared. And again, I had the horizontal and vertical asymptotes at 0. And what did we say? Where did... Right, because what does the x squared do? It makes the y positive. So we still are approaching the asymptotes, right, but not crossing them. So if we have this, if this is rewritten like this, what do I do to this function? I shift it which way? 5 to the right and 2 up, right? So it moves my asymptote 5 to the right and my horizontal 2 up, and I don't have to do anything else, right? That's the easiest way to graph. If you have these as an example, you do not have to find the roots and the asymptotes. You don't have to do anything because you can get it right from the transformation equation. So if you have a simple problem like this, do this. However, comma, we probably are not going to, so it's not going to matter. We're going to have point discontinuity. And what is point discontinuity? It goes where? Yeah, that goes in the middle. And just tell me, what does it mean? How do I find it? If I have a function, it's the whole, and what crosses out? The factors cross out. So do you want me to write it out? So it's the numerator and denominator. So when there's one on top and one on bottom, we're going to cross it out. And then once we find this, this is an ordered pair, right? You end up with the x and the y. So once we reduce, which we've reduced to get our point discontinuity, the next thing we can find is the roots, which is r. Okay? So the r is the x-intercept. And the x-intercept is an ordered pair. You find it after reducing. And if it says to find the zeros, it's just the brackets, right? It's just the x values. And I find these by setting the top equal to 0. So what's the A stand for? And which asymptote? How do I find the vertical asymptote? It's what the bottom equals 0. So I want a unique factor. So I set the denominator equal to 0. So the top is the roots and the bottom is a vertical asymptote. What? Oh, sorry. Okay, so the next one I'm going to go to is the y-intercept because we know the y-intercept. So to find the y-intercept, Isaac, get off your phone. So we're going to substitute 0 in for x and solve for y, and this is always an ordered pair. It's not y equals. Y equals is that's a line. It's an ordered pair. So the next one I want to talk about is the end behavior, which is the E, because we've done this already also. And the reason we separate the end behavior, this horizontal and slant, is because you can cross these sometimes. You can never cross the vertical asymptote. So the horizontal asymptote, we had top heavy, and if it's top heavy, it's none. If it's bottom heavy, it's y equals 0. And if it's tied, it's the ratio of the coefficients. And we said if it's top heavy, it's none, except that's not exactly true, because if it's 1 greater, we get a slant asymptote. And sometimes we call a slant asymptote an oblique asymptote. And we get this when the degree of the numerator is 1 greater than the denominator. We're going to divide and ignore the remainder. we ignore the remainder because at the end, where the x is great, those go to 0. And so we can ignore the remainder. Kind of. We're going to start graphing on Monday. You're going to need this. Okay. So everybody put your pencil down and look for a minute. So the next one says t squared. T squared. So I can have an x squared on top, and I can have an x squared on bottom, right? So my x squared, this is called a duplicated factor. Okay, Natalie, it's not on your phone, it's here. X squared is a duplicated factor. The x is duplicated because I could write this like this. We just don't put the minus 0. Another duplicated factor would look like this. And I can have it on top or bottom. And it's duplicated because it has the even exponent. Let me show you what's not duplicated, because that's what you need to know. So these are all examples of duplication. This is not duplicated. You see the x squared? It has the pluses after it. It's not by itself. This is not duplicated. It has to be in factor form to be a duplicated factor. Does that make sense? Does everybody get that? So another way this could be written, though, because we agreed that x squared by itself is a duplicated factor, it could look like this. And then I have two duplicated factors. I have this and this. They both have 2's. But it has to be by itself. It can't have anything after it. Okay? All right. What? I'm going to show you. So if I have two factors, if I have a duplicated factor, I get tangency or togetherness. Okay? So mine is all like I went over. So if you went over, I'm going to write all the t squared right through here. So I don't know how yours looks. So the question for t squared, do any of the r or a have an even exponent? So in the numerator would be the roots, right? If the top is, so that would be the r. If the r is duplicated, that would look like this. And you would get a tangency or a bounce or a touch. Bless you. So this would look like something like this. It would touch or it would bounce. It wouldn't cross. And we did that already, right? When we did our polynomials. If it was an even, it was just a touch. If the denominator is squared, that's called togetherness. It's togetherness. And what did the 1 over x squared, what did it look like? This flipped up, so these were together, right? So this is either going to look like this or like this. Right? The two go together. we're done.